Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. This is the lecture of IR spectra and lecture number 16. In this lecture also I will explain you factors affecting vibrational frequency, and this is number 9. I have already explained 8 factors which affect the vibrational frequency, and this is the 9th one, which is called vibrational coupling or coupled vibrations. Okay, so first of all, let us understand vibrations. When a molecule absorbs IR radiations, bonds within molecule start vibrating. There are two types of vibrations. Stretching and bending. There are two types of stretching. Symmetric stretching and asymmetric stretching. Let us take example. Methylene group. In this case, carbon is sp3 hybridized. This is methylene group, and here there are two CH bonds. Both bonds have common atom, carbon. Both are symmetric. Having the same bond length. And so they possess same bond strength. Now, when IR is absorbed by these two groups or these two bonds, due to absorption of IR radiations, these two bonds gives two different fundamental vibrations. But as their energy and bond strength is same, these two vibrations, these two bands or vibrations, rather vibrations, not bands, should give only one band because they are same. But it is observed that we get two different bands with different fundamental frequency. Let us see how. As we take CH2 group and if symmetric stretching takes place, then we will have CH stretching frequency at about less than 2900 centimeter inverse. If asymmetric stretching takes place, then CH stretching frequency appear at greater than 2900 centimeter inverse. So there will be slight difference in these two bands. Why? So it is found that when two bonds are vibrating with a similar frequency, then they interact with each other at frequency level, which will cause splitting of one band into two, bands. Here, one with a lower frequency, particularly due to symmetric stretching, and another with higher frequency due to asymmetric stretching. This plating is known as vibrational coupling. Okay, so this is what we call vibrational coupling. Another example is acid anhydride. Acid anhydride has two C double bond O groups. Okay, and there will be two stretchings. One is symmetrical stretching, and therefore C double bond O will appear at about 1760 centimeter inverse, and asymmetrical stretching, due to this C double bond O appear at 1860 centimeter inverse. Though both groups are same, both having the same energy, both are having the same bond length, that means we should get only one band. But here we are getting two bands, which is normally called doublet. And this doublet, in which one has lower frequency due to asymmetric stretching, another has higher frequency due to asymmetric stretching, and this is known as coupling or coupled vibrations. These are called coupled vibrations. Okay, so wherever we have similar bonds, we can observe this one, and it appears as doublet like this. Okay, for example, here this is at 1860 centimeter inverse, and this one is at 1760 centimeter inverse. One is due to symmetric stretching, another is due to asymmetric stretching. So here we can say that both vibrations are fundamental vibrations. Remember this. Symmetric stretching and asymmetric stretchings are fundamental vibrations. Okay. So here coupling occur between two fundamental vibrations. Second thing, coupling of stretching vibrations occur if common atom is present, and coupling of bending occur if common bond is present. So this is very important, that if coupling occur between a common atom is present, then there will be coupling.